Hi all the students of Narayana 9th standard. Today here I am in front of you all to discuss the topic work power energy of 9th standard, and it is assignment number 10. Let us go with the first question. Now here I hope you can observe the question which is given to you all over here is a person compresses a spring a distance of 5 centimeters which requires a force 100 newtons. So here the given data over here is distance is given as 5 centimeters which is CGS unit, and force is given in SI unit which is 100 newtons. So force F is going to be equal to 100 newtons, whereas distance, that is change after compressing the distance, after compressing the compressed distance is nothing but delta x. Delta x is given as 5 centimeters. 5 centimeters. If you convert it into SI unit, you are going to get 0.05 meters. Centi is nothing but 10 power minus 2, right? So now work done over here. So actually the work done formula over here is going to be in a spring force. When you apply spring force, your work done formula is half into kx square. X square is nothing but the distance which the spring has got compressed, right? Now let us talk over here. If you want to solve this sum, you need to know the k value. You don't have a k value in the question, so you have to get it down. So how do you get it? From the force formula, F is equals to kx. F is equals to kx. So here what do you have? See, that means k is going to be equal to F by x. Now your force is given as 100 newtons and your x is given as 5 centimeters which is of 0.05 meters. So 0.05 meters, you are going to get around somewhat 2000 Newton by meter. So when you apply that over here, your work done is going to be equal to half 2000 Newton by meter into x square is nothing but 0.05 whole square. So if you are going to solve this, you are going to get W is equals to 1 by 2, somewhat around 5, because 0.05 square is going to be 0.0025, and this into 2000 is going to be around somewhat 5. So 2 ones are, so 2.5. So your work done over here is going to be 2.5. SI unit of work done is joules. So which option do you think? Option number 1. Done. The first question, I hope it is very helpful for you. You all understood? I think so. So let us go to the next question. Let's see your next question. Here it comes. Here the given data, if you are observing over here, the given data over here is somewhat around, spring constant is given, that means k value is given, that's good, and the change in length is given, that means change in length, that means how much it is compressed. So they extended from 20 centimeters. Already the length of the spring is 20 centimeters. They extended it to 21 centimeters by applying some force. I don't know what is that force. We have to find it out. Now we have a constant, spring constant. It depends upon the material of the spring also, like what material the spring is made and how much of density it is having, right? So anyway, they gave that constant also. Now if you want to find out that, first of all let us find out the change in length. Change in length is nothing but equals to 21 centimeters minus 20 centimeters is going to be equal to 1 centimeter, which in terms of SI is going to be around somewhat 0.01 meter. So your delta x is 0.01 meter. Now what I want spring constant force is also given like 100 Newton by meter. Now what I want is, I want the magnitude of force. Force I need. How do you find out the force? Force is equals to, magnitude of the force is equals to k into delta x. So anyway, the delta x is also found. So delta x is somewhat around 0.01 meter. So if you substitute those values, 100 into 0.01, you're going to get around F is going to be equal to 1 Newton. Multiplication, you're going to get 1 Newton. Let us see which option it is. It is your second option. It is your second option. Right. So 1 Newton is your answer. Let us go to the next question. Hope this is helpful for you. Right. Well, coming to the last question of your assignment, that is third question. Now let us go with this explanation. Let us find what is the given data over here. What is the spring constant? They want K value. That's fine. We have to find K value. A spring that needs a force of 3 newtons to be compressed to 40 centimeters to 35 centimeters. So here the change in length is given. So delta X is given as 40 centimeters minus 35 centimeters. So you are going to get somewhat around 5 centimeters. 5 centimeters is nothing but equal to 0.05. In SI it is going to be 0.05 meters. Now what you do is, force is also given. He has applied the force of 3 newtons. So now, what is the spring constant of a spring that needs force of 3 newtons? So you have to find K. So how do you find K value? F by delta X. So what is your force? 3 newtons. What is your delta X? 0.05 meters. So just try to substitute it. So 3 into 100, you have after decimal 2 points, 3 into 100 by 5, that's nothing but 300 by 5. So cancel it, 5 ones are 5, 60 is 300. So you are going to get somewhat around 60 Newton as a unit of force and meter as a unit of change in length. So you are going to get 60 Newton by meter. So K value is going to be equal to 60 Newton by meter. Now which option it is? It's around somewhat first option, right? So right, we have done it. Now I hope these are your questions. I don't think we don't have some more questions on this spring constant force. I hope you all enjoyed this assignment. Let us meet in another assignment. Bye.